Okay, now another topic which is called imperfections. Imperfections, imperfections or defect in solid. So what is imperfections or defect in solid? Normally in ionic crystal you will get the defect or imperfections inside the solid. So what is imperfections? Normally in ionic solid, as you know, ionic solid contain cations and anions. The cations and anions, they are present in the solid like this. This is cation, this is one anion. They are present in this way. This is anion, this is cation. They are arranged inside the solid like this way. And each ions are bonded with each other like this. Every ions are bonded with each other. In this way they are bonded. Now in this crystal all the ions, cations and anions, they are present in their own position, and this type of crystal in which the crystal having the same unit cell containing the same lattice point means the position of the particle, containing same lattice point, this type of crystals are called ideal crystal. This type of crystal are called ideal crystal. I mean, in this type of defect, there is in this type of crystal there is no defect because all the particles are present in their own position. But in some cases the particles may change their position from this position to that position. You will get some deviation inside the crystal. Then the crystal is said to be said to show some defect or imperfections. Now, an ionic crystal which have the same unit cell containing the same lattice point, then this type of crystals are called ideal crystal. I mean, in this type of crystal there is no defect. But this type of crystal exists only at 0 Kelvin temperature. Only at 0 Kelvin temperature you will get this type of ionic crystal. But if the temperature is above 0 Kelvin, then you will get some deviations from this ideal crystal, and then the crystal is said to show some defect or imperfections. So every ionic crystal shows defect if the temperature is above 0 Kelvin temperature. Only at 0 Kelvin temperature you will get the ideal crystal. Ideal crystal means the crystal in which the particles are present in their own lattice point, there is no disorder, no deviations, then that type of crystals are called ideal crystal, and this type of crystal exists only at 0 Kelvin temperature. Above 0 Kelvin the crystal shows some disorderness or defect and then the crystal is said to show some defect or imperfections. Now, mainly there are two types of defect. One is called electronic defect. One is called electronic defect, and one is called atomic or point defect. Atomic or point defect. Mainly there are two types of defect. Some defect are called electronic defect and some defect are called atomic or point defect. Now, if the defect inside the crystal, if the defect arises due to some electron, due to disorderness of some electrons, then that type of defect is called electronic defect. And if the defect arises due to these particles, I mean, suppose some particle missing from their original position and it will occupy the void. Suppose some particle is missing from their original position and it leaves the crystal, then that type of defect is called atomic or point defect. I mean, electronic defect arises due to some disorderness of electrons, and atomic or point defect arises due to disorderness of particles. So, mainly two types of defect you will get. One is called electronic defect and one is called atomic or point defect. Now, This atomic or point defect, again you can classify into two types. One is called stoichiometric crystal defect, stoichiometric crystal defect, and another is called non-stoichiometric crystal defect. Non-stoichiometric crystal defect. I'll tell you later what type of crystals are called stoichiometric and what type of crystals are called non-stoichiometric. So defect mainly classified into two types, electronic and atomic defect. And atomic or point defect again can be classified into two types, stoichiometric crystal defect and non-stoichiometric crystal defect. Now first time I want to explain about the electronic defect. As you have got, electronic defect arises due to electrons. I mean, when the defect arises due to electrons, then that type of defect are said to be electronic defect. Normally, if the temperature is above 0 Kelvin, then some of the electrons present in the crystal may excited from their ground state to higher energy state. And when the electron jump from their ground state to excited state, then it produces some hole inside the bond because the electron is missing from that position. And due to presence of this hole, when it produces one hole, then the electron from other bond can come from this to this position to maintain the hole. If one electron come from this to this, then the hole will create again here. Again some electron from other bond can come to this position. I mean, the electron are moving inside the crystal due to this defect. And due to this movement of electron, the crystal become good conductor of electricity. So this is also one type of defect which is called electronic defect, because the defect arises due to electrons. I mean, if the temperature is 0 Kelvin temperature, then some electron may occupy higher energy state from their ground state depending upon temperature. These electrons are free to move inside the crystal, and due to this movement of electrons, the crystal become good conductor of electricity. I mean, if the crystal shows some defect, then it becomes good conductor of electricity. But if the crystal is ideal, if all the ions are in their same position, if all the electrons are their own position, then there will be no movement of ions, no movement of electrons takes place. I mean, the ideal crystal become bad conductor of electricity. But if the crystal shows some defect, and due to defect the electrons can move inside the crystal, and due to this movement of electron it becomes good conductor of electricity. So this is the consequence of the defect. If the crystal shows defect, then it becomes good conductor of electricity. So this is about the electronic defect. I mean, if the temperature is above 0 Kelvin temperature, then some of the electron can jump to higher energy state from their ground state, producing some holes, and due to production of holes inside the crystal, movement of electrons takes place, and due to movement of electrons it becomes good conductor of electricity. So this defect arises due to electron. Ions are in same position, only due to this movement of electrons or due to excitation of electron the defect arises. That's why this type of defect is called electronic defect. Now we will move to atomic or point defect. What type of defect are called atomic or point defect? As I have told you, atomic or point defect arises due to the particles. When particles are missing, then this type of electrons will be in the same position, but some particle may show some disorderness. Then that type of defect is called atomic or point defect. Now atomic or point defect arises due to the irregularities of the ions or the particles. Now since atomic and point defect can be classified into two types, stoichiometric crystal defect and non-stoichiometric crystal defect, I mean the defect shown by stoichiometric crystal is called stoichiometric crystal defect, and the defect shown by non-stoichiometric crystal is called non-stoichiometric crystal defect. Now first time you should know what type of crystal are called stoichiometric crystal and what type of crystals are called non-stoichiometric crystal. Suppose there is a solid, for example, you consider sodium chloride. Here sodium is cation chloride is anion, and the ratio of sodium and chloride is 1:1. I mean, according to formula, the ratio of cation and anion is 1:1. I mean, if the number of sodium ion is 100, chloride ion must be 100. So, this type of crystal in which the number of cation and number of anions are exactly same as given in the ratio in the formula, then this type of crystals are called stoichiometric crystal. I mean, here the ratio is 1:1. So if the crystal contain 100 sodium ion, 100 chloride ion, I mean the number of sodium ion and chloride ion is exactly similar to the ratio as given in formula, then this type of crystals are called stoichiometric crystal. But there are some crystal, for example, if you consider nickel oxide, here nickel is cation, oxide is anion. Nickel 2 plus is the cation, oxide O2 minus is the anion. Here also the ratio of nickel and oxygen is 1:1. So if the nickel number is 100, oxygen number should be 100. But in this type of crystal you will get, if the oxide number is 100, nickel number you may get 98. I mean, the number of cation and the number of anion are not same according to the ratio as given in formula. This type of crystals are called non-stoichiometric crystal. Yes, although the number of nickel ion and oxide ion is not same, but as a whole, the solid is neutral. So how it becomes neutral? Actually, this type of crystals are called non-stoichiometric crystal. In this type of cases, what happen? As you know, nickel is one of the transition metal, and transition metal can show variable valency. I mean, nickel can show 2 plus also, nickel can show 3 plus also. And due to its variable oxidation state, due to variable charge, in this crystal, some nickel exists as 2 plus and some nickel exists as 3 plus also. That is why different oxidation state contained by the nickel ion, and that is why nickel number is something less as compared to the cation. And that is why this type of crystal, although their number of cation and number of anion are not same, but electrically it becomes neutral. I mean, total number of positive charge is equal to the total number of negative charge, although the number of cation and number of anion not same. So this type of crystals are called non-stoichiometric crystal, and normally non-stoichiometric crystals shown by the transition metals because they can show variable oxidation state, I mean variable charge. See how it become 98. See, if suppose this is 2 plus ion, these are 1 plus ion, this is 2 plus ion, this is also 2 plus ion, this is also 2 plus ion. Now let's see the number of positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 positive, but there are 8 negative. Na? So it will not be neutral. Na? So that is why 2 positive must be vacant, then it becomes neutral. I mean, total number of positive charge is equal to the total number of negative charge. But let's see the number of cation and anion. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 anion, but you see the cation 1, 2, 3, 4, 5, 6. So here cation number is 6, anion number is 8. So here cation number, anion number is not same, but total number of positive charge is equal to the total number of negative charge. So like this. Here also, since some nickel exists as 2 plus, some nickel exists as 3 plus, so due to this reason, nickel number you will get less, oxide number you will get more. But although the number is not same, electrically it become neutral. I mean, total number of positive charge is equal to the total number of negative charge. And this type of crystal in which the number of cations and number of anions are not same according to the ratio given in formula, this type of crystals are called non-stoichiometric crystal, and the defects shown by this crystal are called non-stoichiometric crystal defect.